Hey guys, just want to give you a little introduction to this lab, help you kind of write up your pre-lab, your procedure, and data table and stuff. It's a pretty straightforward lab. I should have brought home the styrofoam cups to show you those. But it's basically a big styrofoam cup with another styrofoam cup that kind of fits inside of it, holes punched in the top for a glass stirring rod, and a thermometer. And that's where all the reactions are going to happen. This is kind of a crude calorimeter, but it's really pretty effective. It's kind of surprising how good our data gets from these things. So what we're going to do in this lab is we're going to measure the heat from three different reactions. And because the three reactions are basically, it's one reaction and then two steps of the same reaction, we should be able to use Hess's law and see that, reaction A plus reaction B is equal to the overall reaction C. And that's what we're going to try and do. So here are the three reactions. The first one is sodium hydroxide just reacting with water. Now we talked about this being, this is just dissolution, right? We're going to make this sodium into sodium ions and hydroxide ions, right? And that's what's actually aqueous. But that's breaking an ionic bond. And this is actually a pretty exothermic reaction because the associations with the ions and water are so favorable. We're going to calculate a theoretical delta H. And to do that, we need some values that are in a handout that I haven't given you yet. But I'm just going to give them to you here. So the heat of formation of sodium hydroxide as a solid, that is equal to negative 425.6 kilojoules per mole. And the heat of formation of sodium hydroxide in solution as an aqueous is negative 469.6 kilojoules per mole. So you'll need those values to be able to calculate the theoretical delta H, right? Look at what our products are, look at what our reactants are. The water is unchanged, so that's not going to be an issue. The second equation is this one, sodium hydroxide in aqueous form reacting with hydrochloric acid in aqueous form to form sodium chloride in aqueous form, and of course some water, because this is a neutralization reaction. We're going to take the hydrogen off the HCl and the hydroxide off the sodium hydroxide, and we're going to make two H's and an O, that's water. Our theoretical delta H, we're going to need our aqueous sodium hydroxide, which I just gave you, but you're also going to need the standard heat of formation or enthalpy of formation. I should say enthalpy. I was taught heat, and I use the word heat way more than I use the word enthalpy. And so the standard heat of formation of, again, this is of the HCl in aqueous form, is negative 167.2 kilojoules per mole. And we do need the water this time because it's a reactant. So the heat of formation, standard heat of formation of H2O in the liquid form is equal to, it's not that, sorry, and my eraser is apparently not working on my pen again, so that's irritating. So sorry for the scribble, but the water is going to be negative 285.83 kilojoules per mole. And then we also need the sodium chloride, the heat of formation of that, which is again aqueous, so the delta H formation NaCl aqueous form is equal to negative 407.1 kilojoules per mole. So using those values, you ought to be able to get a theoretical delta H for each one of those, and you want to have that ready to go. We're not going to need it till the calculation, so this doesn't need to be in your purpose or procedure, but you can actually start your calculation section too as well and go ahead and do these calculations in there. The third reaction is going to use heats of formation that we've already used. So all of these we've already done. The difference here that this is solid, not aqueous. So we're going to use solid with the HCl. So we're taking the step of sodium hydroxide going from solid to aqueous. That's one step. We're taking sodium hydroxide aqueous with hydrochloric acid to make water and sodium chloride. That's the second step. And then we're going to do the third reaction, which is starting with the solid sodium hydroxide and the HCl. So we're doing those two steps together, basically, to make the sodium chloride and water that we saw in the second reaction. And so this is our overall reaction. And we'll calculate our theoretical delta H. And like I said, you already have these values for the standard heats of formation for each one of those. So that shouldn't be too much of a problem. Just remember, right, the equation we're using is the heat of the reaction, the enthalpy of the reaction is equal to the sum of the standard heats of formation of the products minus the sum of the standard heat of the reactants. And again, you're going to need your M and N. Well, these are all 1, so that's not going to be a problem. Then you're going to check your math. You should get, if A plus B, if you divide that by C, you should get 1. Using all the standard heats, that's just mathematically how that should work out. No problem there. This is one of the things we'll do with our actual data to kind of see if our data support Hess's law. We will have a total of 3 grams of sodium hydroxide available for each group, so make sure your tests don't use more than 1.5 grams, and you'll be weighing it out, and they're kind of in pellets, so you're going to have to, get enough pellets to be close to 1.5 grams, but not be over 1.5 grams. So it's going to be some value that is not 1.5, so you'll need to record that value, of course. Calorimeters work well with the volumes between 20 and 80 milliliters, so think about that as the total volume. You want the volume to be closer towards the 80s. So you want to make sure that the liquid you're adding is going to approximate, 70, 80, 60, 70, 80, somewhere in there. Now, if you think about the data you're going to need, we're going to need the mass of the sodium hydroxide in the first experiment, right? In experiment A, mass of the sodium hydroxide, the volume of water, and you'll need, of course, the initial and final temps. That's what you'll be recording. Then the second one, we've got aqueous sodium hydroxide and aqueous hydrochloric acid. You're going to need the concentration of the sodium hydroxide, which I'll give you because that's something that fluctuates. I'll have to do a titration to make sure we have the exact concentration, and I'll give you that on the day of the experiment. And then the initial and final temps, so that's experiment B. And then for the third one, we'll need the mass of the sodium hydroxide, the volume of the hydrochloric acid, and the final temps. And I'll give you the concentration of the HCl as well. So hopefully that helps you make your pre-lab. And like I said, you can do purpose, procedure, and then you can also go ahead and do the theoretical calculations. Hang in there, you're doing great.